Hey everyone, welcome to our matter classification lecture. Today we're going to be looking at how substances can be classified as an element, compound, solution, or suspension. So let's go ahead and get started here. We're going to go ahead and check out, once again, matter classification. What is matter and how do scientists differentiate between different types of matter? So first off, I really want to make sure we understand like what is chemistry? What are we trying to study in this class? And if the opening slide wasn't a good hint, take a second here and try to write your definition of chemistry down. You could pause the video if you want, but chemistry specifically is the study of matters, the study of stuff, things, and specifically the changes that matter undergoes. So it's important for us to understand what is matter. Not what's a matter, what is matter. Matter specifically is any substance that has mass and volume. Remember, volume is the amount of space something takes up. And mass is specifically the amount of matter that substance has. It's not the same thing as weight. Weight is due to the force of gravity pulling down on us. Mass, once again, is just how much stuff is inside of something. The units for matter are grams. Matter can be subdivided into two categories. It could be divided into first, pure substances. A pure substance is something that has a definite composition. So if we're looking at a pure sample of water, water is going to be H2O. The formula for water is H2O, 2 hydrogens for every 1 oxygen. And that ratio cannot change for pure water. This means a couple things. It means that every sample of a given substance has exactly the same composition. So once again, pure water is H2O, and that cannot change. It also means that every given sample of a pure substance has the same characteristic and properties. So basically, 1 cup of water would be the same as a different cup of water in relation to its melting point, boiling point, chemical properties, physical properties, et cetera, et cetera, et cetera. The other type of matter that we're going to be looking at are mixtures, and mixtures are really just going to be a blend of 2 types of matter. These types of matter usually are going to be pure substances, but a mixture can have more than 2 pure substances mixed physically together. So generally speaking, the substances are in a mixture are not chemically combined to each other. While in that mixture, each substance retains its own identity and properties. And so like if you have salt water, for example, the salt is still NaCl, sodium chloride, and the water is still H2O, water. Kind of a dumb way to look at this, but you can't make water more watery, but you totally can add more salt to make salt water more or less salty. You can change the composition of a substance within a mixture. Now, I really like this dichotomous chain here where we could basically break apart matter into, once again, 2 categories, the pure substances and the mixture. And we can even go one step further in separating the pure substances into elements and compounds. We can also separate the mixtures into homogeneous and heterogeneous mixtures. These are also sometimes called solutions if you're looking at a homogeneous mixture, or suspensions for heterogeneous. So here's a couple of examples of elements. We have red phosphorus here. We have sodium. We have elemental sulfur. And the definition of element is as follows. It's going to be a pure substance made of 1 type of atom. So even though like in phosphorus here, we have 4 phosphorus atoms chemically combined together, it is still considered an element, because an element and an atom are slightly different things. I always like to think of an element as a specific type of atom. By definition, elements are a pure substance made of 1 type of atom. So since these are all phosphorus atoms, this is considered a elemental form of phosphorus. Same with the sulfur. There are 8 sulfur atoms bonded together in an elemental sulfur molecule. Moving on, Let's go ahead and check out compounds here. Compounds specifically are going to be pure substance made of two or more different types of atoms. So you need to have two different types of atoms. Here we have H2O, water, has hydrogen and oxygen. Over on the left-hand side, we have ammonia, NH3, nitrogen and hydrogen. These are different elements. And notice that when we write these things, we don't include a space between the elements. They're written right next to each other. Each new element is signified by a capital letter, and sometimes the formulas for these elements have a capital and lowercase letter. So keep an eye out for that. Capitalization is really important for identifying types of atoms within a compound. Next, we have a homogeneous mixture. Don't forget, this is also called a solution. Solutions are going to be mixtures whose components are uniformly distributed throughout, meaning that the ratio of elements isn't different on the top or the bottom or the left or the right-hand side of the type of substance you're looking at. We have aqueous copper sulfate on the right-hand side. Notice that in these beakers filled with copper sulfate, the blue solution there isn't more or less blue depending on where you are within one of the beakers. It is uniform throughout, and that's because the ratio of copper sulfate is the same throughout the entire mixture. So homogeneous mixtures or solutions, once again, are mixtures whose components are uniformly distributed throughout. And that means that heterogeneous mixtures are going to be mixtures whose components are not uniformly distributed. Oftentimes, these things will spontaneously separate. For example, we have oil and water. They don't mix evenly. Fog is a great example. Sometimes fog can be so heavy that like you can barely see your hand in front of your face. And the other times it's just a light fog out, right? So fog is a mixture of water and air. And the composition of fog is not constant throughout the entire sample size of the fog. So what I want you guys to do here is I want you to practice looking at the different types of compounds, elements, solutions, or suspensions that we could have. I'll help us out here. So earlier up on our previous slides, we actually had brass as one of the examples. Brass is actually going to be a solution. As far as this goes, it's an alloy. Alloys are types of solutions. They are mixtures of metals. So there we go. Carbon dioxide has the formula CO2, telling us that this is going to be a compound. There's two different elements here, carbon and oxygen. We have here iron. Iron has the formula Fe. Since this is the only element, the only type of atom, this is going to be an element. Salt water is a mixture. Specifically, it's a solution. It is a solution. Salad dressing, hopefully we realize this is also a mixture, but this is a suspension. Think about like a vinaigrette dressing. Before you use it, you have to shake it up before putting it on your salad dressing because the salad dressing components, the parts, have spontaneously separated in the mixture. Glucose, we have C6H12O6, C6H12O6. This is going to be a compound. Epsom salt is MgSO4. This is going to also be a compound. These are more than one type of atom bonded together. Chlorine gas is Cl2. So even though there are two chlorine atoms within this molecule, the two chlorine atoms are identical. So this is considered an element. Liquid nitrogen is got the formula N2. Once again, because these are two nitrogen atoms bonded together, they are the same. These are going to be an element. And then copper wire is Cu. Copper is copper, so this is also going to be an element. I like these last three here. The last three have really good adjectives to try and throw you off, but notice that chlorine, nitrogen, and copper are all three elements on the periodic table. All right, y'all. Thanks so much. I hope you followed along with your graphic organizer. Have a great day.